All right, guys. So today, 7.3 multivariable linear systems. Again, sounds very official, very intimidating to some of us possibly. We don't need to be intimidated by these whatsoever. How many of us remember solving three variable systems of equations in previous classes? I'm hoping that we just have a lot of people who don't like raising their hands because we've all seen this before. Again, whether you're in Algebra 2 or Algebra 3 last year, you covered the heck out of this at some point. So the good news, once again, is that you've seen it before. I'm not going to call it bad news, but the realistic news would be that if I had to guess, this was probably not one of your favorite sections or lessons or chapters from Algebra 2, and that's understandable. Is anybody willing to share why, if three variable systems weren't your favorite, what is it about them that you did not necessarily love? McCallum. Just lengthy. Totally agree. Okay. What else? Anything else? Or is that the main issue? Lengthy. Okay. Another one that comes to mind for me, I don't know if anybody else shares this notion, is that if you make even a tiny mistake in the third step, you can do the next 49 steps, and then you get to your answer, and yeah, it's way off. It's really screwed up because I just dropped a negative symbol or something like that. It's very difficult in many aspects to catch your mistakes as you're going. Some of the math problems that we're doing, it's, okay, I can't go on to step 4 because I made a mistake in step 3, so I know that's not always the case. Again, you just keep on rolling, and that's very frustrating for all parties involved, not just the students, but also for me as a teacher. But again, that's absolutely true. So one of the things that I would say is that with where we are right now, I mean, you guys are all in pre-calculus, and obviously everybody, we're all at different levels in terms of we've got, people. I'm saying like your overall grade really is spanning in terms of every student's going to be a little bit different. Grades are not always even 100% indicative of where it is that you're at. So what I'm saying is that we're all over the place in terms of overall ability, but regardless, everybody, just merely by being in this class, you have a lot of math skills and you guys are strong math students. Every single one of you, I'm confident in saying that. So that being said, one of probably the biggest dividers when it comes to, from my perspective, to my students who are working with these three variable systems, the difference between, oh yeah, this student is nailing it, and then this student is struggling, or this student is somewhere in between, it usually has to do way less with their math skills and way more with their organizational skills. Okay? These are the types of problems that you can do. You could run circles around people with your math ability, but if you have garbage, organizational skills, you're going to make a lot of mistakes. It's just the way that it is. If your math ability maybe isn't the greatest in comparison to all the other pre-calculus students, but you're very organized and you're meticulous and you write things down, you're going to be just fine with these types of problems. It's not that the math is difficult, it's just that you have so many things going on. It's all coming at you from different directions. If we can keep that stuff organized and keep that stuff straight, you will be successful with these. So I've got a few things that I'm going to require you to do, all in an attempt to keep you organized. But at the end of the day, you're still going to have to decide to do those things, number one, but then also to just see it through and make it happen. All right? Just like section 7.2, and again, I'm assuming here that if you experience struggles in 7.2, it was with reading the word problems, creating the system. That's likely where our bigger mistakes are going to happen, or struggles, I should say, in 7.3. So we're continuing to work on those skills of reading a word problem and creating the overall system. So the goals we have in place for today: students be able to set up and solve three variable systems of equations. Number 2, students to be able to solve real-world problems with three variable systems. So I kind of mentioned this a few minutes back, I think before I started this video, how the plan is that we'll cover 7.3 today. We're going to review 7.2, 7.3 on Monday, quiz on Tuesday. That's the way it's written up. Please understand that 7.2, 7.3 review probably is going to be way more of a 7.3 review. Does that make sense? So if we need a little bit more time spilling into, that's kind of what Monday is designed for. It's sort of that flexible day. We've got some around the room type problems that we're going to want to work on, but we're also, if we need to finish up a little bit of 7.3, that's exactly what's going to happen. All right, so guys, when we are solving a system with 3 variables, our goal is relatively simple. Yeah, I mean, you talk about huge goal, big goal is to solve for X, Y, and Z. Yeah, but as far as how do we break that down and make it happen, the goal is that we want to take those 3 equations with 3 variables and knock it down to 2 variables with 2 equations. So basically, we want to eliminate a variable. So if throughout chapter 7 and even prior, if I seemed like I was always harping on or pushing, elimination method, elimination method, elimination method, because I know where we're going, and that's here. And furthermore, I know where we're going with matrices coming next. We're going to be using elimination way more often than the others in terms of graphing and substitution. Now, that's not to say that substitution is a bad method, like I said yesterday, but we will use elimination way more often. So, like I said, we are going to be provided 3 variables, 3 equations, or we're going to create 3 variables and 3 equations. And we need to knock that down to 2 variables, 2 equations. Once we have that new system with 2 variables, 2 equations, then it's just like what we were doing yesterday. We can solve those. If we can solve for X and Z, then we can plug those back into one of the originals to solve for Y, and then we have all 3 variables. We're happy. We move on to the next one. Okay? So our strategy for making this happen, you may remember from last year, you may have totally blocked this out and have no recollection of doing this type of work. But the strategy that I would encourage you to really think about, and I understand that right now they're just words. It's probably going to come to life a little bit more when we actually start doing some of the problems. But the first thing we want to do is pick 2 equations and eliminate a variable. Now, on the surface, I'm going to say it doesn't matter which one, because technically, truly, it does not matter which one. But in almost every system of equations, you're going to look at it, and one of the variables is going to jump out as, yeah, let's get rid of that guy. If you already have opposites created, or if you already have opposite signs or something like that, usually one is going to, or 2 sometimes, are going to jump out as, yep, we want to eliminate this one or this one, but we don't want to eliminate that one. That would be too much work. It's not that you can't do it, but one of them usually kind of, the light shines on that one as, hey, this is the one that needs to go. Second goal, or strategy, is that we're going to pick 2 different equations and eliminate the same variable. So if we have 3 equations, I usually just number them 1, 2, and 3. It's like the top, the middle, and the bottom. Okay? So we could combine equations 1 and 2 to eliminate variable x. Then we could combine 1 and 3 to also eliminate variable x. That's how this is going to go. All right? I just said 1 and 2 and then 1 and 3. Maybe it's going to be 2 and 3 and then 2 and 1 or something like that. I don't know. Every problem is going to be a little different. But we're going to choose 2 different ways to eliminate the same common variable. From there, we're going to solve the new 2 variable system, with either substitution or elimination, and then we're going to back substitute to cover all variables. Like I said, a lot of words up there right now. The action is where it's going to start to really come together. So before we move any further, in Chapter 7, they do want us to introduce this notion of what we call row echelon form. Now, you may remember hearing about row echelon form in the past. Chances are you didn't talk about it with systems, you talked about it with matrices, and we will talk about row echelon form, I don't want to say daily, but way more often when we're in Chapter 8 with matrices, because that's a big thing when we get into our matrix notation and matrices and things like that. But it does exist here with systems. In fact, let the cat out of the bag here. The whole reason why we care about systems, to me, frankly, Chapter 7 and Chapter 8 really work together. The whole reason why we care so much about systems is because next what's coming is we're going to be able to put these things into matrices, and now we can use our calculator to do a lot of solving. We could use other technology to do a lot of this stuff. So as far as, if you're ever considering or thinking, where or how is this stuff used in the real world, I doubt that an engineer is sitting down and solving this. No, I agree with you. But they're turning it into a matrix and then plugging it all into a computer or calculator and knocking it out that way. All right? So back to this old definition, row echelon form. We say for a system of 3 equations with 3 variables, row echelon form occurs when there is a stair-step pattern with leading coefficients of 1. Kind of a stupid sounding definition, but that's exactly what's happening here. we have our stair-step pattern, and our leading coefficients are all positive 1. When that happens, we again call it row echelon form. If you ever see this and your job is to solve the system, you should get a big giant smile on your face because these are by far the easiest ones that you will ever do. Okay? The stair-step pattern, meaning that the top equation has all 3 variables, the middle equation is down to 2 variables, bottom equation is down to 1. And if we have leading coefficients of 1 all the way across, like I said, that's just going to dramatically simplify this type of problem. So again, it's much easier to solve a system in row echelon form because we can use that notion of back substitution. So yesterday, all of our answers, if they were not word problems, all of our answers were written as ordered pairs. Today, since we have 3 variables, our answers are going to be written as ordered triples. So x, y, z, this format. All right. So if this is my system, would you agree that we're just flat out given that z is 2? So we already have 1/3 of our answer. Super easy. We didn't do anything other than recognize, oh yeah, I guess that's what's happening. So now, could I plug z in place right here into that first equation? Yeah, that's not really going to do much for us. Would you agree? I don't know what y is, so I'm not going to be able to solve for x, right? So I'm still down to too many variables. But if I plug z into that second equation right here, now we're in business. Does that make sense? Now we can say that we have y plus 3z equals 5, and we know that z is equal to 2. Therefore, y plus 6 equals 5. When I subtract over, now we know that y equals -1. So if we know that y equals -1, we're thinking about this as 2 down, 1 to go. Does that make sense, what we're doing? So now could we take the fact that z is 2, plug it in here, take the fact that y is -1 and plug it in here. So we are plugging in for y and z. And we call this back substitution, rewriting that top equation. X minus 2y plus 3z equals 9. But we know that y is -1, while z is 2. We can clean this up algebraically. X plus 2 plus 6 equals 9. X plus 8 equals 9. Therefore, x must equal 1. So now we know our final ordered triple. 1, comma, -1, comma 2. All right, so guys, you're pretty smart. I bet you remember some stuff. Are most of our 3 variable systems going to look like this? No. It'd be fantastic if they did. I would have had to totally change my original spiel of the fact that usually students don't like 3 variable systems. If they all looked like this, you probably would love them. Okay, because again, how much work did that really require? Very little. This was, as far as the work that we just put into this problem, it felt, I would say, more like an Algebra 1 or pre-algebra, just let's practice substitution type thing, because we knew everything. Everything was essentially provided to us that we were going to need. What we're going to be seeing way more often is something that looks like this. Okay, so this would be a typical problem that we want to be able to jump into. So I don't know. I don't think I'm going to be able to finish this one up in 1 minute and 20 seconds. So I'm going to stop this video here. I'd like for you guys to go ahead and start this one on your own, please.